World War II was a symphony of destruction, but behind every explosion was an idea that transformed metal and mathematics into something terrifyingly precise. Artillery, once the slow heartbeat of trench warfare, became a weapon of intelligence, mobility, and coordination. By 1945, it could see without eyes, move like a tank, and think faster than any gunner alive. 5 innovations changed artillery forever. Inventions born not from luxury, but from desperation. A fuse that could sense its target. A gun that could move with tanks. A system that made an entire battalion fire as one. Rockets that screamed through the sky. And a cannon so huge it needed its own railroad. These weren't just weapons. They were turning points, each one pushing the boundaries of physics, engineering, and fear itself. It began with an impossible question. What if a shell could know when to explode? Before 1940, artillery shells relied on luck and timing. You fired. You hoped the fuse burned just long enough to burst near the target. Too early, wasted. Too late, harmless. Then came an idea so bold, it sounded like science fiction. What if the shell could sense the enemy and detonate itself at the perfect moment? Britain had tinkered with photoelectric and acoustic fuses in the 30s, but nothing worked reliably. The breakthrough came when British scientists shared their secret with America during the 1940 TISAD mission, the same exchange that brought radar and jet research across the Atlantic. In Washington, the task landed on the desk of a quiet physicist named Merle Tuve. He led Section T of the National Defense Research Committee, a project so secret that even many officers using the shells never knew how they worked. Tuve's team had to do the impossible, shrink a radar into the nose of a shell. They built what was essentially a tiny radio transmitter and receiver using a single vacuum tube and an autodyne circuit, a technology that would have been cutting edge even in a laboratory, now expected to survive the fury of a cannon blast. When fired, the fuse would emit radio waves. As it approached a target, a plane, a ship, even a soldier, those waves bounced back, interfering with the signal. Once interference reached a threshold, a tiny device called a thyrotron triggered the detonator. The shell exploded in mid-air, showering shrapnel across a wide radius with deadly precision. Every part of this system had to endure tens of thousands of Gs of acceleration and spin forces that could tear apart anything fragile. Even the battery was ingenious, a glass ampule filled with acid that broke upon firing, activating the circuit in flight. The first real test came in the Pacific. In January 1943, shells fitted with proximity fuses were fired by the USS Helena, and Japanese planes started falling faster than ever before. Against V-1 flying bombs over Britain, the kill rate jumped from 24% to 79% in just 2 months. In Europe, at the Battle of the Bulge, proximity fuses turned ordinary shells into air-bursting storms that shredded infantry caught in the open. General Patton later said, "The proximity fuse won the Battle of the Bulge." He wasn't exaggerating. It multiplied anti-aircraft effectiveness 5 to 10-fold. It reduced wasted fire. It forced the enemy to change tactics overnight. The technology was kept so secret that soldiers were forbidden to recover unexploded shells, lest the enemy discover what was inside. Only in 1954, almost a decade after the war, were the details declassified. A radar in a bullet, a thinking fuse. It didn't just destroy targets, it rewired the very concept of artillery. Tanks could move fast, artillery couldn't, and that single problem nearly lost armies their victories. In the early days of the war, artillery still traveled the old way, dragged by trucks, horses, or manpower, across mud and chaos. By the time towed guns reached the front, the fight had already moved miles ahead. Blitzkrieg warfare changed everything. Germany's armored divisions struck with lightning speed, and static artillery couldn't keep up. Mobility had become the new law of survival. The solution was daring and surprisingly simple: mount the gun on a tank. It wasn't entirely new. Experiments had existed since the First World War, but World War II made it essential. For the first time, entire fleets of self-propelled guns rolled out of factories in mass production. Germany led the charge with the Sturmgeschütz III, or Stug III, a low-profile, armored assault gun built on the reliable Panzer III chassis. Initially designed to smash fortifications, it evolved into a deadly tank destroyer. Cheap to build, fast to produce, and remarkably durable, the Stug III became Germany's most manufactured armored vehicle of the war. When Panzer III hulls ran short, engineers simply switched to the Panzer IV chassis and created the Stug IV. Efficiency under pressure, a German specialty. The Americans took a similar approach. Their M7 Priest mounted a 105mm howitzer on a modified Sherman tank frame. With its open top and pulpit-like machine gun mount, it delivered rapid, devastating support fire wherever armored columns advanced. Troops loved it. It kept pace with tanks, provided instant firepower, and could relocate before enemy counterfire arrived. The Soviets took the concept and stripped it to the bone. Their Su-76 was crude but effective, cheap, lightweight, and deadly in numbers. Soviet engineers built thousands, valuing simplicity and speed over perfection. Crews could repair them in the field with little more than a wrench and determination. Unlike towed guns, these new machines could shoot and scoot. They'd fire a barrage, then vanish behind cover before enemy spotters could respond. That mobility saved lives and won battles. Mounting artillery on existing tank chassis also simplified supply chains. Same engines, same tracks, same parts. That meant quicker repairs, easier training, and fewer logistical nightmares, a godsend in the chaos of total war. The results were staggering. By 1945, the Allies and Soviets had produced more than 200,000 tanks and self-propelled guns combined. Together, they became the rolling thunder of modern warfare, able to support infantry, chase down retreating enemies, or plug gaps in collapsing lines. For the first time, artillery could advance with the spearhead instead of lagging behind it, and that changed everything. Self-propelled guns didn't just keep up with the tanks, they became tanks' silent partners, the shadow firepower behind every breakthrough. Their success redefined modern doctrine, leading directly to the mobile howitzers and armored artillery vehicles we see in today's armies. The age of static guns was over. Artillery had learned to move and never stopped. Artillery is only as good as the brain that controls it. And during World War II, the United States Army built one. It was called the Fire Direction Center, or FDC, a revolution not in steel, but in mathematics. It didn't fire shells. It calculated when, where, and how every shell should land. In the chaos of the battlefield, artillery once operated like isolated thunderclaps, each battery firing at its own pace, its own target, guided mostly by estimates shouted over radios. It worked, but it wasn't precise. Fire missions were slow, coordination was messy, and friendly fire was an all-too-common horror. That all changed in the late 1930s at the U.S. Field Artillery School at Fort Sill, Oklahoma, where a visionary named Carlos Brewer began to reimagine the entire system. He proposed something radical. What if artillery could act as a single, synchronized weapon, controlled from one nerve center that did all the thinking? By the time America entered the war, Brewer's idea had become reality. Every artillery battalion now had its own fire direction center, a hub filled with maps, slide rules, weather data, and men trained to perform complex trigonometry faster than most people could read. When a forward observer spotted an enemy position, He didn't call every gun directly. He called the FDC. There, a team calculated range, azimuth, elevation, propellant type, and charge. They accounted for air temperature, wind, humidity, and even the curvature of the earth. The data was sent to every gun in the battalion simultaneously, meaning dozens of artillery pieces could now fire together with the accuracy of a single gunner. It was revolutionary. The FDC also enabled something that stunned enemy forces again and again, a tactic known as time on target, or TOT. The idea was simple but devastating. Make every shell from every battery strike at the exact same second. The execution, however, was anything but simple. The FDC calculated each gun's distance and time of flight to the target. Then, using synchronized watches, gunners fired at staggered intervals so that every shell arrived simultaneously. No warning, no gradual barrage, just instant annihilation. The first major use of this came in North Africa under British command, but the Americans perfected it in Europe. At Elsenborn Ridge, during the Battle of the Bulge, 3 divisions, 129 guns, fired as one. The German infantry never stood a chance. Reports describe waves of soldiers cut down before they could even dive for cover. For the first time, artillery had become coordinated intelligence. It could think, plan, and strike with precision measured in seconds and meters. By 1945, it was estimated that up to 60% of all enemy casualties inflicted by U.S. ground forces came from artillery fire, a statistic owed largely to the Fire Direction Center system. The FDC made artillery flexible, deadly, and reliable. It reduced mistakes, prevented friendly fire, and allowed commanders to shift hundreds of guns onto a single target within minutes. This wasn't just about firepower, it was about control. Artillery was no longer the brute force of the battlefield. It was the brain and the beating heart of every American offensive. They didn't whisper through the sky, they screamed. To soldiers on the ground, it sounded like a chorus of demons. The air itself seemed to split apart as 1,000 rockets shrieked overhead. Then came the impact, not precision, but overwhelming chaos. The ground shook, the air burned, and in seconds, entire positions simply vanished. This was the dawn of rocket artillery, and it forever changed how armies thought about firepower. Before the war, rockets were little more than curiosities, unreliable, inaccurate, and hard to control. But desperation, again, breeds innovation. Both the Soviets and Germans realized that what rockets lacked in accuracy, they made up for in sheer volume. The Soviets were first to master it. In 1941, as the German invasion tore through their defenses, a new weapon rolled onto the battlefield, the BM-13 Katyusha. Mounted on trucks like the Z-6 or the American Studebaker supplied through Lend-Lease, it could unleash up to 48 rockets in less than 10 seconds. To the Germans, it was pure terror. They called it Stalin's organ, because the launcher's tubes resembled the pipes of a church organ, and their sound was anything but holy. A single battery of 4 launchers could saturate an entire square kilometer with explosives. At the regimental level, hundreds of launchers firing together could bury enemy lines in flame and shrapnel before a single soldier advanced. Meanwhile, the Germans weren't far behind. Their answer was the Nebelwerfer, a 6-barrel rocket launcher originally designed to fire smoke rounds. But as the war dragged on, those smoke rounds were replaced with high explosives and soon with massive 28 and 32-centimeter rockets that could obliterate anything within range. The Germans nicknamed their own creation Heulende Kuh, the Howling Cow. Allied troops gave it another name, the Moaning Mini. But despite their terrifying noise, both the Katyusha and the Nebelwerfer had the same weakness: accuracy. They weren't designed to hit a target. They were designed to erase it. Both sides learned to deploy their launchers in large groups, firing salvos that blanketed wide areas. It wasn't about precision, it was about psychological warfare. The noise, the vibration, the chaos, it broke morale before it broke bones. Rocket artillery was cheap, fast to build, and devastating in numbers. The Soviets could mass-produce them by the thousands, using simple steel tubes and welding equipment. By 1945, over 10,000 Katyusha launchers had been produced, with millions of rockets fired across the Eastern Front. Reloading was slow. A launcher could take 10 minutes to prepare for its next barrage. But the damage was already done by the time the enemy recovered. The launchers were gone, having driven off to new firing positions. At Kursk, Minsk and Berlin, the Soviets unleashed these weapons in thunderous waves that shook the ground like earthquakes. Entire German divisions were buried under rolling storms of fire. The Germans, in turn, placed their Nebelwerfers closer to the front lines, often in forests or ruins, supporting infantry attacks or sealing off retreats. But their thick smoke trails gave away their positions, forcing them to relocate constantly or face immediate counter-battery fire. Despite their flaws, these weapons were more than just loud spectacles. They redefined modern artillery doctrine. The principles born from the Katyusha and the Nebelwerfer became the foundation for every post-war multiple-launch rocket system, the American MLRS, the Soviet Grad, and countless others. The battlefield had changed. Artillery no longer needed. To aim perfectly, it only needed to arrive all at once. And with that, war found a new language, one spoken in fire and thunder. They were not weapons. They were monuments, each one a symbol of industrial arrogance, born from the belief that if you built a gun big enough, you could rewrite the laws of war. They were so vast they required their own railways, their own crews, and sometimes their own cities. These were the railway guns, the largest artillery pieces ever built by humankind. Germany led the obsession. By the late 1932, as Hitler prepared for continental domination, Krupp engineers unveiled their masterpiece, the Schwere Gustav, a weapon so enormous it defied reason, a 4-7-meter-long barrel, a total weight of nearly 1,350 tons, and a shell that weighed 7 tons, each one the size of a car, capable of traveling nearly 30 miles. It took 4,000 men and 6 weeks to assemble. Once operational, it required 2 parallel railway tracks and a small army of engineers just to aim it. Every shot demanded precise calculation, wind, temperature, curvature of the earth, all to drop a single shell on target. It was first used during the siege of Sevastopol in 1942. For weeks, the Gustav rained down shells upon Soviet fortifications dug deep into rock and concrete. Each impact was cataclysmic, carving craters 30 feet deep and collapsing entire bunkers in seconds. But as impressive as it was, the Gustav was also a paradox. Its power was unrivaled, but its practicality non-existent. It could only move along fixed rail lines, making it an easy target for airstrikes, though the Luftwaffe's dominance at the time spared it. Its rate of fire was painfully slow, 1 round every 45 minutes. And after just a few dozen shots, the barrel needed replacing. Yet for Hitler, it was more than a weapon. It was a statement proof that German engineering could achieve the impossible. Other nations followed with their own experiments. The French had their cannon de 340 millimeters, the British revived their BL 18-inch gun, and the Americans tested railway-mounted artillery along the Atlantic coast. But none matched the sheer audacity of the German designs. Even more outrageous was the Landkreuzer P-1500 monster, a planned vehicle that would have mounted the same 800 mm gun on tracks. It was never built, but on paper it would have weighed 1,500 tons, too heavy to move, too large to hide, too absurd to exist. The Germans eventually realized the truth. Mobility had become the king of the battlefield. Aircraft, rockets, and fast armor made these steel giants obsolete before they even fired in anger. The Schwerer Gustav and its sister gun, Dora, were retired and later destroyed to prevent capture. Their shells remain massive, rusting relics of an era when men thought size alone could decide wars. But in their echo lies a haunting lesson. Technology without adaptability is just vanity forged in steel. The titans of the railway age did not shape the future, they marked the end of one. They were small, cramped, and smelled of diesel and fear. Inside, the air was thick, part oil, part sweat, part dread. Yet from these steel coffins came one of the most cost-effective and terrifying weapons of World War II, the submarine. They didn't need speed or armor to win. All they needed was stealth and patience. The Germans called them U-boats, Unterseeboot, undersea boats. To the Allies, they were a plague that haunted the oceans. By 1941, they weren't just ships, they were hunters, slipping silently through the depths of the Atlantic. A single U-boat could take down cargo ships worth millions of dollars, carrying food, fuel, and weapons vital to Britain's survival. It was asymmetric warfare at its purest, a cheap machine capable of crippling a nation's economy. Each U-boat cost about $5 million to build, roughly the price of a single Allied destroyer, yet could sink hundreds of thousands of tons of shipping before being caught. In 1942 alone, German submarines sank over 1,100 Allied ships, cutting deep into the Atlantic lifeline. The ocean became a graveyard. Convoys burned in the night, their flames stretching across the waves as crews clung to wreckage in freezing water. The U-boat captains called it the happy time. For the Allies, it was anything but. The U-boat fleet operated in wolf packs, coordinated groups of submarines that stalked convoys together. Using encrypted radio transmissions and tactics refined by Admiral Karl Dönitz, they could strike from multiple directions, overwhelming convoy escorts. But the real power of the U-boat wasn't in numbers. It was in the fear they created. Every merchant sailor knew that beneath the waves, unseen eyes were watching, waiting. Every ripple could be a periscope. Every shadow could be death. And yet, the advantage didn't last. By late 1943, Allied technology began turning the tide. Sonar, depth charges, radar-equipped patrol planes, and escort carriers made the ocean less forgiving. Submarines that once prowled with impunity now became prey themselves. Still, the U-boats refused to vanish quietly. They evolved faster, quieter, deadlier. The Germans introduced the Type XXI, the first true submarine designed to stay submerged for long periods using advanced batteries and streamlined hulls. It came too late to change the war, but it changed naval warfare forever. Across the Pacific, Japan's submarines hunted U.S. carriers and freighters, while American subs turned the tables, cutting off Japan's lifelines and sinking nearly half of its merchant fleet. By 1945, submarines had rewritten the rules of naval warfare. They proved that you didn't need a massive fleet to bring an empire to its knees, just a handful of quiet killers beneath the waves. From the depths, they taught a simple truth. Sometimes, the most effective weapon is the one the enemy never sees coming. War learned to fly and to kill from above with terrifying economy. As the war ground on, aircraft stopped being just scouts or fighters. They became flying artillery, cheap, fast, and able to deliver death where guns could not. Bombs grew smarter in delivery, if not in guidance. New aerial munitions let commanders rain destruction without investing in gargantuan, immobile pieces of steel. One strand of that story is the rise of the glide bomb, the first practical precision standoff weapon. The Germans led with weapons like the Fritz X and the Hs-293, guided by radio from the launch aircraft. They could ride a slow, steady arc into warships or hardened targets, bypassing some of the quirks of unguided bombing. In September of 1943, a Fritz X scored a direct hit on the Italian battleship Roma, detonating magazines and sending the ship to the bottom. It was proof that a relatively small, cheap munition, when guided, could sink capital ships. Then there were the smaller, brutal innovations, rocket-assisted aircraft ordnance and unguided rockets fired from fighters and ground attack planes. The Il-2 Sturmovik and the British Typhoon fired rockets that turned fighters into flying tank killers. A column of tanks could be shredded by a few well-aimed salvos from aircraft that needed only minutes over target. No railway guns, no long preparations, only speed and surprise. The Allies answered with innovations of their own. Tactical air power learned to mimic artillery's massed effects, concentrated fighter-bomber strikes, dive bombing with pinpoint timing, and the use of proximity-fused anti-aircraft shells to clear the skies for bombing runs. The proximity fuse that made naval gunners lethal also protected bombers, and conversely, aircraft forced artillery to adapt with better camouflage, dispersion, and mobility. Cheapness mattered. Mass production meant aircraft could deliver vast tonnages of explosives quickly. The U.S. industrial machine turned airplanes into factories of death. Thousands of sorties, each one a potential ballista. Carrier aviation multiplied reach, land-based tactical aviation compressed response times, airborne delivered ordnance became a new, flexible layer of fire support. In Normandy, at Arnhem, and across the Eastern Front, air-delivered explosive power proved decisive in shaping the tempo of battle. But there's a darker side. As aerial ordnance became more effective and cheaper to produce, destruction became more indiscriminate. Cities that once might have been bypassed were leveled in the name of supply interdiction or tactical advantage. Glide bombs and rockets introduced the capacity to find and smash a target without committing whole armies. That asymmetry reshaped the moral calculus of war. So the sky joined the land and sea as an artillery domain. Aircraft didn't just carry bombs, they extended the reach of artillery doctrine, teaching commanders that mobility plus volume was often better than sheer size. The lesson carried forward. In modern war, the cheapest delivery method that can reach a target first often wins the day. By 1945, the Thunder had changed its rhythm. The massive railway guns, for all their theatre, felt like relics beside the whine of rockets, the electric snap of proximity detonators, the rumble of tracked self-propelled guns, and the quiet efficiency of an FDC that could choreograph 100 pieces of steel into a single, lethal heartbeat. Submarines taught navies the value of stealth over mass. Aircraft taught armies that speed and altitude could replace a siege. The war didn't just add new tools, it rewired how commanders thought about force, logistics, and time. These five, and the cousins we touched here, did more than win battles. They set the architecture for modern firepower. They taught the Cold War planners how to build systems that emphasize mobility, massed effects, precision delivery, and automated control. They taught engineers the value of survivability under impossible stresses. Proximity fuses surviving tens of thousands of Gs, SPGs being repaired in fields with ragged tools, rockets launched from simple tubes that cost a fraction of a heavy shell. Still, technology is an amplifier of human choices. The proximity fuse saved lives by increasing accuracy and reducing wasted fire, and it made the sky a deadlier place. The Stooge and Su-76 protected crews and delivered support, and they also made mechanized slaughter more efficient. Rockets terrorized soldiers and civilians alike. The Gustav impressed and underlined a truth. Scale without agility is vanity. So ask yourself this. As the echoes of 1945 fade into the present, Did these innovations shorten the war by making strikes more decisive, or did they simply turn destruction into something faster, cheaper, and therefore more likely to be used? The answer is not neat. What is clear is this: the innovations of World War II did not die in 1945. They evolved, they multiplied. They taught modern militaries how to think about firepower in terms of information, speed, and volume, lessons that still shape battlefields today. The guns never really stopped firing, they only changed their voices.